Okay. So now we are going to see about the RSA algorithm. RSA algorithm is developed by Ronald Rivest and R.D. Shamir and Leonard Ariban. So they developed in the year of 1977, which now till now it's most famous algorithm used by Microsoft, Nokia, and Cisco. In 1997, they just patented this algorithm. Okay, and since this algorithm is more complicated, it's all based on the factoring difficulty. Okay, let's because of time constraint, let's go fast. So RSA algorithm. So RSA algorithm, we have a 7 steps of in order to encrypt the data. So the first step is choose two large prime numbers labeled as P and Q, and then multiply P and Q, we can label it as N. So before choosing E, we have to assign a value for pi of n. So this pi of n is nothing but here it shows. In order to choose E, we need to first find out the pi of n. So before choosing the E value, we need to assign a value for pi of n. So pi of n has a formula called like a p minus 1 times q minus 1. So this using this assigning value, we can easily find out the pi of n. So after finding the pi of n, we have to choose a E. It has to satisfy these two properties. That is, the E should be greater than 1, but it should be less than this pi of n. Okay, so that's how we used to find the encryption lock key, that is E comma n. Now the sixth step is choosing the D. D is nothing but the decryption. Okay, this has a formula called DE mod pi of n is equal to 1. So I'm just gonna use the same formula in a different method. So while I'm doing demonstration, you will understand. So decryption unlock key is nothing but D comma n. So this n and this n are same. Okay, this n and this n are same. All right. So let me give you the demonstration of this RSA algorithm. Step number 1, we have to choose a value P is equal to, I'm choosing value P is equal to 3 and Q is equal to 5. Step number 2, we have to multiply this P into P times Q, that is N is equal to P times Q, that is equal to 3 into 5, that is 15, right? Step number 3 is, this is 1, this is 2. Step number 3 is we have to assign a value of pi of n, right? We have to find out the pi of n. Pi of n is nothing but P minus 1 times Q minus 1, that is 2 into, so P minus 1 means that is 3 minus 1 is 2 and Q minus 1 is 4. So 2 4s are 8. So now the pi of n is 8. And step number 4 is choosing so basically now what we are doing is we are just finding out the encryption lock key and then decryption lock key. We are going to find encryption lock key and we are going to find the decryption lock key. So using those keys, we are going to encrypt the data and we are going to decrypt the data. So that is what I'm just doing a demonstration here. Okay, so fourth one is choosing E. That has to satisfy two properties. So choose E, so that is 1 is less than E, and then E should be less than this pi of n. Okay, so we have to choose in order to choose the E, we have a pi of n 8, right? So what we have to choose a number which it should not have a common factor with this 8. Okay, so we should not have a common factor with this 8. Okay, so therefore I can choose number 3, because 1 always common factor goes with every number, and 2 also shares a common factor with this 8. So now we are going to see 3 doesn't share a common factor with this, so I'm going to write 3 and then I'm going to write 5 and then so this why I'm writing up to 7 means it has to satisfy the e should be, we can take any random number, but I'm gonna consider another property called GCD, that is most greatest common divisor, that is 7 comma 8, it satisfy the 1. So that's why I'm just choosing this 7. So now the e satisfy this condition, right? So 7 is always greater than 1 and less than the pi of n. Pi of n is nothing but the value 8, right? So I can write like this. Okay, so now we have found out the e. So the lock key, encryption lock key, I can write as e lock key, encryption lock key, that is, so what we have found is encryption lock key is e comma n, right? So e comma n, so e is nothing but 7 comma n is 15. So this is a lock key, encryption lock key we found out. Now we are going to find out the d. Okay, so here I'm using the formula called d is equal to 1 plus k pi of n divided by n. So I'm gonna choose a value here. In order we need to find out this k in order to satisfy is equal to 1, that is equal to 1. So we need to find out this k. So how we are finding we can find out the k should always less than that e. So e is nothing but 7, right? We can just find out the iteration of this formula from 0 to 6. So if you do from 0 to 6, so the 6th value will satisfy this condition, d is equal to 1. Okay, so that's why I'm choosing this 6th value. So I can write it here, 1 plus 6 of 8 divided by 7 is equal to 49 by 7 is nothing but 7. So this d is equal to 7. It's always less than the k satisfies, that is less than the e, and also it satisfies 1. So now the d is equal to 7. The unlock key is again d comma n is 7 comma 15. Okay, using this key, encryption lock key and unlock key, that is decryption unlock key, so we are going to find out, okay, we are going to find out the encryption and decryption process. I'm just taking okay, let me draw it here. So I'm just choosing a letter B. So we can assign a value that is for alphabetic order along with the a to a is equal to 1 and b is equal to 2, so until it goes to z is equal to 26 letters, right? So we are going to assign a value in an alphabetic order, like a is equal to 1, b is equal to, until z is equal to 26. Okay, so for encryption process, so I'm assigning that is message is equal to 2, that is I'm choosing B letter. Okay, just don't get confused. So I'm just taking the letter B, so that value is 2, message is 2. So here there's a condition, there's a formula that we are using for ciphertext. C is equal to 2 power e mod of 15. Okay, so this 2 is nothing but whatever the message that plain text is to the power of e into times of mod 15. So 2 power e is nothing but 2 power 7, so e is 7 mod 15. Okay, so now it gives us like a 128 mod 15. So so mod I'm sorry. So here is equal to 128 mod function of 15. So that gives 8. So mod function is nothing but 128 divided by 15. Mod is always taking the result of the remainder, not the quotient. So it always take the remainder value. That's a result of this mod value. Okay, so 128 divided by 15 means so if you basically if you put let me see. Yeah, so 128 divided by 15 times means so we get the remainder value is 8. Okay, so you can do the calculation. So for time constraint, because I'm just going fast, so C is equal to now 8. So 8 denotes the letter called H. So now the B is converted into H. Okay, this is a ciphertext. Okay, now we are sending this H into the network. On the receiver side, they used to decrypt this data. They're converting this H to B. So again, so the message now it becomes as a 8. So already we have seen whatever the message it to the e power mode of 15, that we are going to see the same thing. We are going to see the decryption process. So in decryption, so this is encryption, and now we are seeing the decryption. Okay, so 8 to the power of 7 mod 15. So that gives value like 2. It's already a calculator. So 2097152 mod of 15. So if you divide this value by 15, so you will get the output as 0. Sorry, not 0. So I'm sorry. So is equal to 139, 810.133. Okay, so in order to find the remainder results, so we need to multiply 15 into this decimal number. Okay, so if you multiply, so that's giving a remainder. So that's the concept. So 0.133 into 15, so it will come like 1.995. So you can take it as a round off like a 2 value. Okay, so now the plain text message after decryption, we are getting the same value. So you can check a calculation this, you can check all this calculation, so you will get the same output as 2. Okay, so this is a basic demonstration of this RSA algorithm. Okay, so next we are going to see about the hash